Here we are. Thanks for coming. Thanks to the organizers for inviting me. So come with me this morning on my journey as a senior developer and cloud architect in my work learning to visualize cloud systems that are serverless, principally. In this journey, we will cover the key clients I've been working with my team over the past couple years, and I'll talk about, through some stories, visualization wins and losses, and it's really a journey rather than a destination. One of the reasons I've chosen to give this talk across Europe, I've been in Berlin and I was in Serbia earlier this year, is I'm trying to raise awareness around this topic for our community. And so, as I said, there will be some practical information if I do what I intend here, but there's also some aspirational content. So I'm trying to aim for a mix of both. We'll see how we go. So the question that is really motivating this talk is, why do system pictures matter? Aren't we developers? Pictures don't do anything. What is the point of a picture? Why is it important? What is the impact of effective visualization on the performance and reliability and security and so on of our serverless distributed systems? Does it matter? When has it had an impact? When has it been successful? When not? So to get us started thinking visually, what kind of snapshot where we are? Pick your favorite vendor. I'm sure all of you in this room either have worked with this kind of architecture or soon will be, because otherwise I doubt you would be at Serverless Conference. This is, if you're not familiar, a sort of classic serverless reference architecture from what is in my world with my clients, the leading vendor, which is Amazon. And if you look at this picture, there's a good amount of information conveyed, both by the text, but also by the visual aspects. The different shapes for the services, the different colors, so on and so forth. It's really interesting because, as was said in the introduction, although I do quite a bit of work with Amazon, I do an equal amount of work lately with Google Cloud, and in the past I've done work with Azure, and I'm in fact starting to do work with a fourth cloud. And this is a similar type of reference architecture from that fourth cloud, Alibaba. So it's interesting to look because, as with many other aspects of serverless implementation, Amazon leads the way, and visually they do as well. It's pretty obvious when you compare that which vendor pays more attention to creating differentiation in the picture of their system currently. And you might say, well, this is, we're developers. So what? So what? So I'm going to hopefully show you through some experiences with my clients that even at this level, it matters. And so given that it matters at this level, what then do we need to be thinking about and going for aspirationally as we work in this industry? Also, I'll call out, did you notice that in the compute layer, this is not a pure serverless architecture? This is a mixed architecture. This particular reference implementation has both stateful compute, which is through servers, for the product service and the inventory services, so EC2 instances, and at the data layer. This is transactional database. So one of the aspects of working in serverless, and this relates to visualization, is, in my experience as a cloud architect, it's very rare to have a pure serverless architecture. The vendors will tell you that's the way to go, and they'll show you a lot of examples of how great it is using Hello World. But one of the reasons that I talk to audiences around the world is to share my experience, because I've built a lot of systems. I've been working with serverless since really the beginning of serverless, which wasn't Lambda. It was S3. And really the next layer of serverless wasn't Amazon. It was Google. It was App Engine. And then Google again with BigQuery. So although market share was gained through Lambda, justifiably, the serverless story is not one of just Lambda, and that's part of our story. Again, back to the visualization aspect. So you may have not caught these details, but I'll bet for sure you didn't catch these details. This is a CDN and this is OpenSearch. And it's really difficult visually to parse that this is function compute, which is Alibaba's Lambda. This is Table Store, which is their DynamoDB. Now, I like to pick on Google because they're easy to pick on. When I started first working with GCP, Google didn't find it necessary to provide any icons whatsoever. And I literally drew reference architectures for GCP serverless solutions using Amazon icons. It was embarrassing. And once Google did provide some icons, they kind of did the same thing as Alibaba. To me, it shows a lack of attention to the importance of visualization. And you might say, well, again, aren't you just, do you have too much time on your hands to think about these things? No, I actually have had clients who've said, if you can't draw me an architecture, I don't feel comfortable. This is actually driven decisions. So Amazon, of course, is building services at a really astounding rate. I joke that I have to literally open the console and click refresh to see what is available today. And if I have to do this and I spend 25% of my time studying just to keep up on things, how can possibly then my clients navigate this? Is there some visualization that we can provide that can help us, our teams, and people we work with to navigate this world of serverless services? Because it's really not just Lambda. It's becoming pervasive across all tiers. So again, I just want to emphasize that in my experience, because Amazon has paid the most attention, and this is Amazon architecture kind of summarized, this has actually drove a selection of vendor. So yes, I am trying to shame the other vendors into being better. That is part of my talk up here, because I would like to have a level playing field. So at a serverless conference that's being attended by mostly developers, I know I'm a bit running against the tide, because what the expectation is that I'm going to talk about this, and I'm going to talk about this a lot. And I'm going to talk about this in super great detail, and how to optimize, and how to avoid cold starts, and how to do all the things you need to do. And you know what? I'm not. Because there's a whole bunch of other talks about that. And that's Amazon Lambda. That's super important, but that's super well covered. And you should go to all those. Lambda is the core of serverless architecture. Most every serverless architecture I've built, but importantly, not all of them, have Lambda in them. And that's what I just said. Not all the serverless architectures that I build have Lambda in them, which may be new to your thinking. So how do I think about a minimum viable serverless architecture? I don't think about that. I think about this. This, to me, represents the different components that I will be dealing with in any architecture of anything that I build. And I think at each layer of component, can it be done serverlessly? And I actually don't start at the compute layer. I start at the data layer. So maybe the first thing I think about is, can I use a DynamoDB table? Or should I use RDS? And my decision vector will be, is the data transactionally interacted with? Because we all know that relational databases are superior for transactions generally. Am I going to use an object store? How, or S3 bucket in this case, how are my clients going to understand how to properly secure the data? Which in my case, with my client base now, is health data. So I don't have the luxury of having clients that misconfigure the public data, because, and it just goes into the newspaper and it's embarrassing. There would be actual criminal consequences because of the health protection laws. It has to be done correctly. And to that end, the next level I think about in building these architectures is, can I apply the security serverlessly? So in this case, can I use a system like Amazon Cognito for federated authentication rather than rolling my own? You notice, is it just painful for you? Are you saying, is she never going to show Lambda? Does she not use Lambda? Is she crazy? What is she talking about? No, it's the order in which I think about things. I think about the data first, protecting the data next. And then I might use something like certificates, which is a serverless service. Available these are Amazon, but it's all the major vendors. Then, yes, I'm going to add some compute. So maybe Lambda, maybe not. And then interestingly, at the top layer, above Lambda, how am I going to process the information? I think this is a real mind shift for us. Most developers tend to think, well, I have to write all the business logic and create my own services, and then maybe I'll write them in Lambdas or whatever. One of the architectures that I built, a couple years ago now, was one of the first in the world, was on the Amazon IoT serverless infrastructure, so the IoT broker, and which supports the protocol MSMQ and certificates for devices and so on and so forth. But when I think about serverless architectures, I think at these 4 levels: at the data level, at the security level, at the compute level, and at the sort of the processing the information level. Which serverless services are available? I would argue that one of the biases we have to think about in our industry is not enough of us understand the importance of effective portrayal of services. That we think just a wall of blue icons is good enough. It's really not. Another way to think about this is one of the hottest areas of my work is machine learning. I am so in demand, I'm actually giving away business. So if any of you are machine learning experts, I get more requests for business than I can do. And so I'm actually mentoring a few new entrepreneurs, and I try to give away business to trusted people. I don't have any connections in London, and so if any of your consultancies or firms specialize in this, come talk to me. But anyway, so how does serverless factor into machine learning? Does it? Don't you just, isn't it stateful? Don't you just stand up maybe containers and run your, custom algorithms? Well, maybe. So one of the things I do in addition to building things is I'm an educator. And in the past, I did classroom education, but of course that's changed to online. So now the primary delivery vehicle of my courses is LinkedIn Learning and lynda.com. I have 30 courses on cloud and data topics, and I have over 4 million views, which results in a whole lot of interaction with people who are learning to develop in the serverless platform, because I try to answer all the questions from my students. Not always able to, but I try to. So in the machine learning area, I myself was struggling, and I actually was working to create a course. And one of the things that I did was I created this visualization for the course. And the reason I did is because I couldn't understand the landscape of the services that were available, in this case on the Amazon cloud, to deliver machine learning. And so I categorized them by a, to me, familiar subset. So infrastructure as a service, platform as a service, software as a service. So this top level is particularly interesting, which are the machine learning APIs. In addition to the other work I do, I volunteer quite frequently as a judge at hackathons for universities. And so one of the things that I would do is I would often show the students the new APIs for machine learning, and I would be astounded at what they were able to build in a weekend. And I thought, I really have an obligation to explain this to my customers and my developers so they can understand the business value that services like recognition, which automatically labels images, could provide to their business. And interestingly, if you think about this, this layer on top is serverless. So when I think about cloud services, whether it's at the security level or at the data level or at the compute level or at the processing level, which I would include machine learning, I think about each level this way. What is the infrastructure service, so EC2 at compute? What is the PaaS level, so EKS, so managed containers? What is the SaaS level? The other thing is, of course, I work across clouds. And so I have found useful to take this kind of visualization and to do it across clouds, because I'll go into companies and help them to figure out which clouds are going to be strategically best for them. So I don't know, I've had a lot of good feedback in that having these two diagrams side by side is helpful in determining what services are available. Now, those of you that have very keen eyes might notice that here you have the blue, right? And here, let me get this off, you have this additional thing called AutoML, which is really quite innovative and not available in any other vendor. Get quite a lot of questions about this. This is serverless machine learning, where you provide, in the case of, let's say, images, your own labels for the images, and you pay for the compute time by the hour. And Google determines the most effective machine learning model, including the parameters for it. And they do that by implementing a grid and implementing hyperparameter tuning, and show you the results. Again, when I've worked with the university students, I've had university students build things on AutoML for vision and text in a weekend that just blew my mind. And I feel compelled to share this information with my business customers. So this method of laying out the serverless services through visualization is almost a pre-architecture, figuring out for those different 4 windows what type of service to use. All right, I've worked for many years. I'm 20 years in this business. So I did, web apps, mobile apps. But again, that's going to be covered very heavily here. I did IoT. I was lead architect on an IoT project 3 years ago that went to production in 10 months. So have a lot of great stuff to share about that. Didn't have time to put it in this talk, but some of the visualization questions I have resulted from that work. Where I've been working recently, and my biggest interest is big data pipelines. I just truly enjoy helping customers take their data and getting business value out of it. And so I've worked in New York, in London, in fintech, in ad tech, in education, in some of the biggest data pipelines in the world, like breaking data centers. It's been really fun. So serverless obviously comes into play here. So what is the biggest big data challenge now? It's DNA data. So a couple of things happened in my life 3 years ago that shifted my professional focus. The first of which is my then 17-year-old daughter got the opportunity to take a cancer bioinformatics course at Stanford in the summer. And she went there and came back and said, "Gosh, Mom, these people really aren't using the cloud." And I said, "What? Are you kidding me? It's genomic data." At that same time, Google came to me and said, "We have a bioinformatics client and they're having scaling problems. Would you like to work with them?" And I said, "Well, I have no domain knowledge of bioinformatics, but this is really compelling. I mean, look at that. By 2050, it's predicted that 50% of the humans on the planet will be sequenced. And look at the volume, the price coming down versus Moore's Law. It's just an incredible volume of data. It's something I've never seen before. And of course, the implications could be profound. As I age, unfortunately, more and more people I know are being impacted by diseases such as cancer. And I am seeing that these DNA experimentation is resulting in immunotherapies and personalized treatments. So this became very, very personal 3 years ago when, very unfortunately, really close friend of mine named Terry was diagnosed with breast cancer. And she was unable to participate in any of the immunotherapies. Now, very fortunately, she survived, but she suffered through some of the most, I would call it, inhumane chemotherapy. I've come to learn quite a lot about this, and if any of you have had this situation or had a relative, you probably know. I mean, the simplest way is chemotherapy is very similar to ingesting bleach. And I said, really, this is just not acceptable. And I really want to work in this industry. So I'm kind of, I don't know, either full of too much confidence or something. But I always joke I don't have a television. And so I will watch Illumina sequencing videos rather than the next survivor. And maybe that's how I got here. But in any case, 3 years ago I knew nothing about this. But I just said, this is where I'm going to work. And I started actually by volunteering. One of the things I do in my professional career is I build in about 20% of the time to volunteer so that I can stretch myself. And I said, I'm just going to try to make an impact in this industry because I have some knowledge that I think could be helpful. So the second thing that happened was, of course, I'm from America, but this project with Google, they said, wow, you had success. There's a conference on this in Australia. Would you like to go? And I said, okay. And so I went, and I was the only person presenting on the implementation of, it was containerizing the technology at the time, at this bioinformatics conference, who wasn't a PhD bioinformatician. So it was quite intimidating. However, there were some people there from the, it's called CSIRO, the Commonwealth for Scientific and Industrial Research Organization for Bioinformatics of Australia. They were attending the conference. And they had done some really interesting work that was serverless. And I knew about it because it was published on Jeff Barr's blog. You probably know about him. He's the chief evangelist. They had attended an AWS summit, and they had this computational problem to help them in their research around immunotherapies for cancer. And this is their tool that they created. It's basically a website. It's called GTScan2. They call it the Google for CRISPR. CRISPR is cutting the gene and editing the gene and trying to repair the gene and then reinserting it in so that the treatment is more like your own immune system is kicking in. It's far less invasive than chemotherapy. It's really quite innovative. So that's all wonderful. But what's germane to this talk is this is the architecture. They attended AWS Summit, they saw a serverless architecture, and this is key. They saw a picture that they could understand. They went back, graduate students, and said, well, let's try. And they built it. And it worked pretty well. Before I came to Australia, this was published on the Amazon blog as one of the first pure serverless implementations in bioinformatics. I said, I have to meet these people. So I went up there, and they're really great people, and they said, all right, we built the system, but we have a problem. It doesn't perform great. And I said, okay. And they said, okay, Miss Cloud Architect, what can you do to fix this? And thank goodness, the stars kind of aligned. I said, well, have you looked at your logs? Because you all know, of course, you can't SSH into a Lambda instance, right? You have to look at the logs. And they said, yeah, we can't really read it. We don't really know. And this was a couple years ago now. And so what did I do? Oh, I looked like such a hero because in one day, we sped this thing up by 80%. Did we just read logs for 24 hours? Is that what we did? Did I just go in the hotel room and just look at the logs? Well, heck no. I used X-ray. So X-ray is one of the first cloud-native log visualizers. There's many other out there. There's people that are creating independent log visualizers. They're super important. Second aspect of the visualization story. We have to have usable log readers. One of the aspects of working with log readers that I've seen that I'm really feeling positive about, particularly for Amazon, I think Cloudcraft is one that does this, is the integration of costs. Because we all know that Amazon does not really work hard to make the costs of their services transparent. They don't really. The joke is, if you have EC2 instances turned on in another region, they don't really make that obvious in the console because that's maybe 25% of their revenue. I don't know, just thinking. But in any case, from a visualization standpoint, having log visualizers was key. All kidding aside, we improved their performance by 80% in one day. So because they had a picture that they could understand, it was really interesting. They had, one of their researchers was from China, and they replicated GTScan2 on the Alibaba cloud. And I would argue that because they were able to understand the architecture because Amazon communicated via picture, they created a picture which then could be used to communicate with the Alibaba architects who helped them, that they were able to get the system up and running. So I believe, and this is an anecdote, I've had other examples of it, that having an architecture that fits on one page is key to building a system that a team can work on. In fact, they've had subsequent success. They've built serverless beacon and tribes using a similar type of architecture because they were able to understand how a purely serverless, burstable architecture works on Amazon. They were able to apply that to their computational problems. Now, so we worked on that. But in the world of bioinformatics, there's lots of problems because there's lots of data. And there's lots of different tools that they work with. So they said to me, okay, we have another challenge for you. And that challenge was to take a customized machine learning library that they had written in Scala, which I'll point out was a language I did not know. And it was basically a splitter. So it split, and this is to find variants. It's sort of the pre-processing before CRISPR, in the full human genome, which is 3 billion letters. And so they would examine chunks of it at a time. So any of that done machine learning, usually you do 10 or 100 features. They do 10,000 features at a time. And again, because it's a technical audience, they built on top of Spark. And so they use Spark executors in memory. So they split both vertically and horizontally. So they had this library that they were using. And again, kind of like the other example, it was working for them, but they had a little problem. They had no cloud implementation. It was an HPC cluster, so they had to wait, kind of in the queue with the other researchers. And if and when they could get access, it took a whopping 500 hours. And honestly, my mouth dropped. Because coming from ad tech and fintech, where a second was too long, I really thought, I am now convinced that I can make a difference in this industry. Because if these poor researchers think that, well, we just have to wait 500 hours when we get access, and that's good enough, I said, that's not good enough. I said, this is a really hard problem. I don't know how long it's going to take us, but we're going to get there. We're going to get there. And in getting there, which we did, I learned even more about visualization. So the first thing that we did, this is very anti-intuitive, because we're all, builders, and so, oh, it's a hard problem. Let's go. Let's containerize. Let's serverless. Yeah. Nope. Let's build a hello world. Let's make sure the thing is worth scaling. Okay, I really want to emphasize that, because this is a pattern that I've had success with across my career. We have to see the viability of the thing we're trying to scale. How many people want it? How usable is it before we invest our time in making it serverless, for example? So what we did is we made a fun toy example. What Variant Spark does is it detects the variants in the human genome that would make up what's called a phenotype, which is a disease. So we couldn't have cancer because it's public data. So these people have a good sense of humor, Australian. So they made a fake phenotype. Hipsterdom. Are you a hipster or not? So they actually made this reference example and a little infographic with 4, and these are actual genomic traits. So it's like, genomically linked. Do you have facial hair? Do you have a beard? Do you prefer coffee? And then what do your eyes like because of checked shirts? It's kind of weird, but it's published papers. So anyway, so we made this, and then I said to them, okay, I don't want a bash script because it's not interactive. We need to start moving this to the cloud. So how do we do this? How can we have serverless Spark? That's really the top of the sort of difficulty level. Well, we went for a SaaS solution. We made our Hello World on Databricks, which happens to run on Amazon. And we made a Jupyter notebook. Now, interestingly, we visually refactored as we presented to audiences because, how remiss, we didn't have a woman. Oh, it was embarrassing. But anyway, so the point, though, is the lead from the group, Dr. Dennis Bauer, and I gave a keynote on this topic and on the potential of this algorithm across APAC. We gave 7 different keynotes. Anyway, so what are you talking about? I want to hear about Lambda. What are you talking about? Well, when you are moving to serverless paradigm, you have to have a lot of technical talent. How do you grow your team? How do you get interest? You have a hello world. Dr. Bauer now has a team that is double the size. Her research budget was doubled. This project was selected in the top 5 for all of CSIRO, for all of Australia, because of the media attention we got and because of the researchers who could easily spin this thing up serverlessly in a way. You just go to the Databricks Community Edition, you spin it up for 5 minutes, you run it and you go, hey, this will work for my research. Then you worry about scaling it. So just like I said in terms of visualization for the services, I made those pictures of machine learning to figure out which ones to use, the pre-architecture. The pre-scaling is to make a hello world with a picture that people can easily run in 5 minutes. Of course, we did scale it. I would be, not probably standing up here if we didn't scale it. We took the 500 hours and, yep, we did it. Serverless, 10 minutes. Woohoo! That was super exciting. It took us, I didn't stay there, work all the time, but it took us over a year to get there. Because when we started, they had one person who was a grad student who knew about the cloud. This was super ironic. I went on Skype with him, Arash, and he said, I know your voice. He had watched my Linda videos to get the job. I am not kidding you. And I'm like, well, you get me in person now. So Arash now has 4 or 5 other full-time colleagues. And the story of what they have done with this one machine learning library in their move towards serverless and cloud has several aspects that have a visual component. So what is the first thing that we did? Did we go directly like Lambda serverless? Did we just go from, on the cloud, on the on-prem to the cloud? No. The first thing that we did was a lift and shift, because I'm practical, and they had no knowledge. Now I know how unpopular to talk at a serverless conference about don't go serverless. Again, I just love the fact that I don't work for anyone except my customers, so I can tell you the truth. Sometimes in the enterprise, going serverless is the absolute wrong decision. If you have no one that has any cloud knowledge, don't be ridiculous. Try to take the knowledge that you have and just get it up to the cloud. So the first thing that we built, this is an EMR cluster. We didn't go raw EC2 because they would have to admin Hadoop. And there was a lot of things to learn. We started with clicking on the cloud console. So I was really aiming to make us this simple picture. Now, I don't think I fully succeeded, but happily they were able to get this knowledge, and they now use this as one of their base architectures. And they did get from 500 hours to a number of hours here. Of course, as a technical team, when you have a success, you get a little arrogant. So it's like, yeah, we did it. All right, so now Spark can be controlled by Kubernetes. So you sit with your technical people and you go, let's do it. So we did, and that's how we got to minutes. So we did this a couple of years ago. So we were one of the first people in the world to build a Spark-based cluster to run burstable compute. So is this serverless at the compute level? No, it's container-based. We built custom containers. Was it a phenomenally hard amount of work? Yes. That we were blazing a new path. So controlling Spark with Kubernetes and controlling your cluster with Kubernetes with Spark on it. The tuning of it just took weeks and weeks. In any case, was there a serverless aspect? Yes, it was at the data level. And this is a point I really want to drive home, because I see that I watch a lot of serverless conference content, and I attend serverless conferences. Please, if you take nothing else out of this talk, it is not just Lambda. You can get business value out of applying serverless concepts at the 4 different levels of the windows. So in this case, we got rid of the Hadoop file system, and we replaced it with a data lake with S3, and we saved a whole bunch of money and a whole bunch of time. So we were really excited. We were like, we did it. 10 minutes, phenomenal. And made a picture. Everybody can understand it. And we did it on Terraform, so you can run on any cloud, just like they did with the other thing. And I published it. It's all on Medium. All the code is there. So if this happens to be your business problem, have at it. It's fun. And then I said, OK, let's build some more, because we have built this part. And I built this, but I wanted to now pre-process the data and really go to town on Lambdas. We're going to do it. We're going to all have it through a Jupyter notebook, so it's just sort of seamless. It's like a simple application for the bioinformaticians. But we ran into a problem. Even though I went out to Australia, I worked with the growing team. They were able to run the Kubernetes solution. They didn't feel comfortable. They was kind of too much new. Because they want to replicate this out for other researchers, and they need to support it. I'm not going to support it. And so I really came to this sort of critical junction, and it drove me thinking about this topic of visualization more deeply. I pride myself as an educator. And I say as a consultant, I've done my job when I obsolete myself, when I've passed along all the information and I've built a system that the client can run on their own. And the client couldn't run this system. And I thought to myself, I have redrawn this architecture. I have rewritten the instructions. I have made what else should there be so that this client can use the system? And one of the big blockers was, what's code? As developers, we like to think about our Lambda, node code or whatever it is, that's the code. And what I'm finding as I work with more serverless architectures, basically have more pieces to them. Yes, there is the business logic code, but as that is sort of out there, what is happening is the configuration code is going like that. Because as you have more pieces, you have more and more configuration code. In some cases, this was one of them. We had more Terraform files than we had Spark files, Scala files. Way more, like 3 times more. And I think that's a reality that I don't hear talked about very much in the industry this way. So if we have 3 times as many code files that are configuration. How do we deal with that? How do we think about that? I was reading a book about, I don't know, it was scaling machine learning or something, and it had literally pages and pages in the book of YAML files. Oh my God, I'm really interested in the topic, and I was just falling asleep in the book. You know what I mean, right? I'm like, I need a visualization. So before I got into this architecture world, I did a bunch of work in a different world. And I thought to myself, did I just do that? Did I, with this sort of drawing, did I just do this kind of thing for architecture? And I thought, I think I did. And I was thinking about our own bias, and this is particularly pervasive in serverless. We're clever. My team was part of it. We were like, we're going to do it. We're going to, go to the next level. And the solution we built for lift and shift is what the client is using. It worked for them. And we have this bias towards complexity, and it's hidden in these piles of YAML files. So I would argue that effective visualization would help us see this bias and counteract it. So this was recent. This was this week. And from Twitter, right? So the things that we're doing are inadequate in terms of visualization, and we know it. So the previous work that I did with data was around an old technology, OLAP cubes. I don't know if any of you know of this, data warehousing. I actually wrote 3 books on SQL Server, and I was the world expert on OLAP cubes, and this is a multi-dimensional data structure, and so I did a lot of thinking. I built a lot of these. This, by the way, since we're a developer audience, this is the MDX, multi-dimensional expression language. The point, though, is because I had this experience working in this world for about 5 years, I had a lot of experience working with situations where you'd have too many dimensions of information. And I started thinking about this as it's applied to architecture and visualizing systems. Because a very well-known thing in the world of data visualization is humans comprehend at most 4 levels of information. Okay, I really want you to take that away. 4 levels, plus or minus 1. Now, there are some people who have, the 5% that can do 7 or whatever it is. But because I always had people coming to make their cubes, because it's 3 dimensions there, but you could make them at first 128 dimensions and then infinite. And so, a problem I had when I was teaching this was people would come and, well, my boss said that 125 dimensions was not enough. We needed to have 15 more. And I said, you need a new job. So I'm a nerd, and I love reading academic papers, and so I started thinking, okay, our industry, our cloud architecture, we're not doing enough in terms of visualization, so we needed to look in other places. And I have all the references in the list, so you can get it. I started reading about dimensionality of visual space, a visual interaction framework for dimensionality reduction based on data exploration, understanding visualization, a formal approach using category theory, the geometry of visual data, early modern contemporary approaches, and then a whole lot with machine learning. So MNIST is the hello world of machine learning. It's the categorization of digits using deep neural networks. So an exploration of dimensionality reduction. So I was really looking all over the place. And my educational background is not in math, it's not in computer science, it's linguistics. So I always tend to think of the problems in words. So from Wittgenstein, if we spoke a different language, we would perceive a somewhat different world. So how do we need to speak differently? Recently, I moved across the country in the US. After 20 years in California, I moved to the Midwest to be closer to my family. So I was putting together a lot of IKEA furniture. And I'm thinking, what is a universal visual grammar? That, is it IKEA? Is that what we need for should we base it on this? Then another problem that I was working on for a client is I had to do a graph translation between 2 workflow languages. The top one is CWL, the bottom one is Nextflow. And I need to make a translator or da-da-da. And I was like, how do I build this? Is this applicable to architecture? Can I translate Amazon to Google? Is this what we need? And I was really thinking, because again, the linguistic background, what is the dialect? What's the dialect we need for our systems? What is the words? And then, of course, as is typical, I was on holiday with a friend, and I was in Sedona, Arizona, And we were so struck by the scenery in our Airbnb that we just literally didn't leave the balcony and just sat there and drank wine and had a beautiful day. And I thought, I just have to really get beyond words. Words are inadequate. It is a visual dialect that we have to work towards to explain our systems in a picture. So what is the dialect? How do we find it? So this is art from MIT, and it's showing the investigation of different biologies. So as you know, I've been working in bioinformatics. So one of the things in bioinformatics is there's a lot of complex processes that need to be communicated to the bioinformaticians, because with the amount of data, there are new types of research that are becoming available. So guess what they use in bioinformatics to communicate these complex concepts? Dynamic visualizations. So I was watching this. We won't watch all of it, watch a little bit of it. The sound is great. This part's really cool. Ready? Here it comes, here it comes. And so anyway, I could totally watch that all day. But what happened when I watched this 8-minute movie is I understood some key concepts of RNA transcription like I had never understood them before, even though I read many things. And I had the insight. It was like, oh, our systems are not furniture. They're dynamic. It's like biology. I know. I'm a little slow, but that's, that was my insight. Let me see if I can get this back where it was here. So I feel after that we need to aim in a different level in terms of our visualization tools. We need to picture living systems. When you think about it, serverless in particular, it bursts, it contracts, different parts come up and down. If we're using best practices, we inject chaos monkey type viruses. It's very biological. It just seems so clear to me. So again, drawing from data visualization. There's a man actually based in London. He runs Information is Beautiful. He's a journalist. I've attended several of his seminars to gain insight in visualization. He says data visualization is all about the melding the visual and the conceptual. And interestingly, when I attend those seminars, I'm the only programmer. Again, challenge to the industry. It's all designers. And he has many, many well-written books that I'm, again, consulting, thinking about how to build tools to visualize. But it's challenging, because my tool is words. It's not pictures. So how can I, as a person who can't draw, who's not visually inclined, make visualization tools? How can I even make a presentation? I spend hours and hours on this presentation with every detail because I have to make a good-looking presentation. You can tell me how I did. So anyway, I did some work way back in Africa, some volunteer work, health work. And it always struck me because African people will always invite me to sing and dance. And I said, I'm not a good singer, I'm not a dancer. And they said, what? They said, if you can walk, you can dance. If you can talk, you can sing. This was in Zambia. And it wasn't, they said, there's not a concept of you can't sing. It's like breathing. And I thought, maybe I should think about visual aspects and visual systems like that. So just like with coding, how do you get better at coding? You code. So one of the media that I work in is photography. So, I'm no expert, it's a hobby, but I've really upped my game in photography because that's where I feel comfortable. So one of the things for you to think about if you're interested in this is how can you practice looking at the world, not with words, with sounds, but visually. Will you paint? Will you use photography? Will you draw? What will you do? This is really putting myself out there because I feel I have no skill at all at drawing. But in terms of triangles, we all know the triangle kata, right? So I thought, okay, I'm going to try this. So, I literally was just doodling around one night, and I thought, okay, this is just a practice. It's a visual kata rather than a coding kata. So one area for us to work in is to up our own game in terms of working in a visual medium. Because as developers, we tend not to do that. We go right to the code. So how can we make tools that visualize if we don't visualize? So, again, I'm just traveling around. I've been in Germany for a while. This is from a sketching architecture museum. I'm tending to, go out and look in the world and see what's there. Looking at how things are visualized. This is Visualising Dance. Think about this. If this was your system moving and flexing, I don't know, this is way out there. But I think we need to go way out there because of the complexity of our systems. This is from biology. Another aspect of this is beauty. Why should our visualizations not be beautiful? Why should they look like that ugly pie chart? One of the feedbacks I got when I gave this talk in a different place was they thought it was interesting, but they thought my architectures were ugly. And I said, gosh, I need to emphasize that more because that was actually the point. I think they're ugly too. So we need to, build tools where they're not ugly, where they're visually appealing. This is very subtle, but I think very profound. In the IoT project, we had lots of people coming and going. And in serverless, new technology, so you're going to have a lot of contractors and stuff usually. So I'm a big fan of Asian art. And a thing that's prevalent in Asian art is it's not important what's shown, but it's important also what's not shown. So the correlation in terms of system visualization is how do we visualize what we choose not to include? How do we show by not showing? Interestingly, a developer who I much admire wrote a blog post about negative architectures, Michael Feathers. He says, the guarantees form a negative architecture, a set of things you know can't happen in pieces of your system. And so my challenge here would be how do we portray that visually? So the bias that we've had in visualization of systems is we didn't look outward. And that's the aspirational part of the talk. Because we don't have infinite time, I would point you also to a developer called RIT Victor. He has a number of prototypes of visualization of dynamic systems on his website that I think are quite promising. And I would encourage you to take a look at if you're interested in this space. However, I'm practical. As much as I like to be a dreamer and go to art museums and dream about things, we build things that are for the world that work. This, by the way, is a flow cell, which is how DNA is sequenced. And one of the situations I had with one of my clients is because they were inspired by the work I did in Australia. I got a new client because of that, a rather important one, and they showed me their sequencing facility, which is one of the largest in the world. Anecdotally, it's in a beer cooler. The human DNA cells are stored, which is quite funny to me that what was a beer plant now has the largest repository of human DNA in the world. Just an anecdote, I don't know. Anyway, so what can you do? You're sitting in here going, gosh, what this lady is talking about art, what am I supposed to do, okay? So practical stuff. One of the things that I have done, in addition to the bioinformatics work, is I worked with Technologies, which is geospatial APIs, kind of like a Google Maps, but more functionality and commercial. And germane to this conference, they were one of the first people who had, and actually we built them, reference examples in the serverless application repository. And I have a series of articles on Medium about the architectures, and one of the things that we did there is we did the what I call 3 to 5 aspect architecture. We were really going for broad reach, and I wanted the picture that everybody could understand, and we had a whole lot of success. So it's a concept that I'm trying to apply. No more than 3 to 5 aspects on an architecture, you have to have a separate page, which might sound ridiculously oversimplified, but if people don't understand the picture, it's not going to get built. And that, of course, applies back to our story of Variant Spark, because although we built it, they didn't use it. Interestingly, I need to take my own advice because the architecture that they released on the Amazon site has, guess what? 3 aspects. A little bit embarrassing, but it's always good to show your own failures. So if you remember back to that story, Variant Spark was in a public repository and had very few users, and the dream of the Australians was to put it on the cloud in a way that was reproducible and usable across the globe. And I'll say in all ways, we've succeeded. Because not only did they build this architecture, but much to my delight, they are, as it says, the first public sector organization in the world to publish a machine learning-based health product on the AWS marketplace. So, you know, I maybe don't have a large amount of data points, but I think I have significant data points. Remember, these people had a part-time grad student who knew nothing about the cloud, and they are now working in the most innovative way across their technologies, and that's the size of their team. And I would argue that it all started with the picture that Amazon presented at the AWS Summit that allowed them to build GTScan serverlessly. So pictures matter. So what about this? You know, I don't want to give up, right? I'm kind of dogmatic. Well, what happened because of the CSIRO is I got introduced to the lead architect of the Broad Institute at MIT and Harvard, is where that sequencing was done, and they happened to build a prototype that was on the Google Cloud that ran 400% faster, which I was actually studying to build the thing for Australia. I got invited to come out and work with them. The product is called Terra. And as you might wonder, did I get the Australian solution, Variant Spark, to work on Terra? Working with the team, I did. And we used the Hello World example, and we got it up and going in 1 day, which further broadened the reach of their work to the very important research community at the Broad. Again, the visualization story is we had a Hello World example, which we could get going very quickly. The next step is here in London. Yesterday, I was at the Imperial College of London, and we are attempting to replicate the work and to move their research onto the cloud serverlessly on platforms that include the Broad's, Terra, and others. So this is a key slide. If you want to take a picture of this one. The slides will be available too. These are the 5 things, because of course I can't have more than 5, right? Plus or minus 1 for 4. Otherwise I'd be violating my own principle. So it's my learning. Visualize your entire system. Code, configuration, and data. That's a tall order. It's not a completed action. It's a work in progress. Use visual grammars. Account for bias. Reduce dimensionality. That one's relatively easy. Show 3 to 5 aspects max. Show system state over time, and verify that your pictured objects can be reproducible. Now, I would be completely remiss if I didn't have an aspirational goal. So to close out today, I'm going to have a little bit of talk from this woman from the Broad. It's 2 minutes. Let me just skip this up here.
My name is Guhapriya Ranganathan. When I came in here, I had no idea what exactly I was going to do. Because one of the things that the people at Broad in the Science Art program had specifically asked me was whether there could be a contribution that art could directly make to one of the science projects. And that was something that was very interesting for me. It was a big risk or experiment, as you say, but I thought that I should try it if given the opportunity. And one of the projects I think that I could easily relate to in sort of visual terms was Erez Lieberman's project, in which I felt that there was something happening with the lines that he was showing me in the fractal patterns that I felt actually spoke to me, and I felt that there was something that I was missing out in what he was showing me as his paper. And so I went back to it, and we started modeling and working on the structural works of it. My interest in Erez's project became so focused that everything that I was looking through got seen through his lens. And through how I saw his project and how it would, because it created a problem for me where the fractal pattern, which is the Hilbert curve, as he showed it to me, had 8 segments, which were untangled, which was equidistant segments. So how was I able to, while he was interested in folding it and making it into the small structure that it is, I was interested in unfolding it. Only when it unfolds, it can pass on information, give instructions, and the whole thing, and sort of runs the life all ourselves, initially started taking it as just mapping memory of something moving. And then seeing how the memory of maps, because maps and memory is something that I've been working on for the last 5 or 6 years in my work. That got interesting for me, and I was thinking of how do I do this as in terms of my own personal memory. And so I started doing a series of prints based on the structural patterns that he was doing and the maps in my life. One of the best things about the residency was I got to print some of my blogs in the lab, in the cancer lab. So I would have a lot of people walking around, working alongside. While they work with their tools, I would be doing my prints every Friday morning. And I would be pulled in and I would see some of their work on their projects. They even took time off to show what they were doing inside, bringing out samples and showing me all sorts of interesting stuff, giving me books to read, papers, all sorts of information that just flowed, even discussions about what is life, what is art. One of the main questions that I heard most people ask me was, what does it mean to be creative? Initially, that was very interesting for me because I've always thought of everybody as being creative. There's not one single person on this earth who's not creative.
I think that's a really, really good way to explain this last picture. So this is my challenge to everyone attending and who watches this. The picture here is very significant in the world of chemistry. It earned Venki Ramakrishnan and his team and some other teams around the world the Nobel Prize in Chemistry. It's a very interesting book, recommended. It's a visualization of the ribosome. It took a great number of years and had a profound impact in this industry. And the challenge that I have to all of us is, what will our picture be? Now, because I like to always leave the audience with something extra, I have all the presentation links here. I will make this presentation immediately available, and I will show you that I have a bonus section. So if you download the slides, you will see the vendors that I'm watching, many of them are here, and the visualization tools that exist today that I think are really interesting. So with that, I really appreciate your attention, and I hope you enjoyed this talk. Thank you.